Okay, girls, people were asking about question 9 in exercise 10.1. I'm just going to bring you back to Pascal's triangle. 1, 1, 1, 1, 2, 1. Remember that? 1, 3, 3, 1. And the term on the next row is the sum of the two terms above it. So the 4 is 1 plus 3. This 6 is 3 plus 3. This 4 is 3 plus 1. You've got ones all down the end. Now, that's using just numbers, but you can write Pascal's triangle in this notation here. Remember, these are the coefficients of 1 plus x to the power of 0, 1 plus x to the power of 1, 1 plus x squared. These are the coefficients of all of these expansions. Now that to the 0 is 0, but you can write it as 0c0. 1c0 is 1, 1c1 is 1. See the coefficients of 1 and 1. Here, the coefficients of this expansion are 1, 2, 1. So you write them as 2c0, 2c1, 2c2. The coefficients of this third expansion are 1, 3, 3, 1, if you were to expand 1 plus x cubed. And you write them as 3c0, 3c1, 3c2, 3c3. Now 3c0 equals 1. 3c1 equals 3. 3c2 equals 3, and 3c3 is equal to 1. What would be the next row? What's the first one? 4c0, 4c1, 4c2, 4c3, 4c4. Now, if you were to do those on the calculator, 4c0 is 1. Anything c0 is 1. 4c1 is 4. 4c2 is 6, 4c3 is 4, and 4c4 is 1. Do you remember these? So these are the same as those. Okay? Now, we also notice, for example, that with this addition, for example, 3 plus 3 is 6. Yeah? So 3c1 plus 3c2 is 4c2. Now, if we look at these numbers here, 20c7, what would be the next row here? I'll just write one more row. 5c0, c1, c2, c3, c4, 5c5. But what we notice that, for example, 4c2 equals 3c2 plus 3c1. So notice this ends in 2, so it's the row above it, the 3c2 and the one before it. So if we look at our question here, 20c7 would be here, 19c7 would be there, and 19c, what would be here? 6 would be there. So 19c6 plus 19c7 equals 20c7. So by just looking at this, we know that k is 6. Okay? That's from using Pascal's triangle. Now, did people try and do it by proof? Yeah. Did anyone get it by proof? Yes. All right, we'll try it. All right, we're going to try it by proof. Let's try. We're trying to prove 20c7 or to work out what this... You could just... No, solve, just give an answer. If you have to prove it, you've got to prove it. Solve is just to give the answer. Can everyone see that 4c4 in the corner, I'm sure? So let's look at this. All right, 20c7, what is it? 20 factorial over... So I'm going to try and 7 factorial over 13 factorial is 19 factorial over...
Miss, would you rearrange it to 20c7 minus 19c7 equals...
All right, we're going to try in a minute, just one sec. All right, let's just write down what each one is. Oh, you're going to make... I do 20 times 19, maybe 7 times 13 times 12 factorial. I don't know.
I started working out a bit, but I rearranged
K factorial.
19c2.
I haven't tried this yet, so I'm not sure what I'm going to do. I've got that. What do you think you do?
20 times 19.
Why don't we take this one over the other side so that we've got the unknown here? All right, so let's go 19 factorial. Actually, let's just, can I put it over here? So 19 factorial over k factorial times 19 minus k factorial. Doesn't that equal 20 factorial over 7 factorial, 13 factorial, take away 19 factorial over 7 factorial, 12 factorial. You know what I've done? I've written this one on the left equals that minus this one. Got it? Now, we obviously can't subtract these because why? The denominators are different. So what's this one missing? Do we really want to do that, or do we want to change? I think we have to, don't we? Did you times this by 13 on 13? So the right-hand side is 20 factorial over 7 factorial, 13 factorial minus 13 times 19 factorial over 7 factorial, 13 factorial. Because what we've really done is multiplied this second fraction by 13 over 13, giving us this, now this 12 factorial changes to a 13 factorial. So we've got the same denominator, 7 factorial over 13 factorial is, well...
Yeah, that's where I stopped.
All right, we can't do this. Why don't we change this into 20 times 19 factorial? Isn't that what 20 factorial is? 20 times 19 factorial minus 13 times 19 factorial. See, they're not like terms, so you can't subtract. Denominators are the same now. 20 factorial is 20 times 19 factorial, so wouldn't this be now, what is it? 20 lots of 19 factorial minus 13 lots of 19 factorial are 7 lots of 19, no, not 7 factorial, 7 times 19 factorial over 7 factorial, 13 factorial. Well, only one of them. That would now be 6 factorial. So this becomes 7 times 19 factorial over 7 times 6 factorial, 13 factorial. We okay with that? So the 7's cancel now and we get 19 factorial over 6 factorial, 13 factorial. Now if you compare that with the left-hand side, therefore k has to be 6 or 13. But in this case up here it's 6. Yeah. No. It doesn't matter which way they're written. But if you look at this, we're expecting to get 6. But look, 9C6 is the same as 9C13, so it wouldn't matter. Okay? So if you're just comparing that with this, we're just comparing those two. Comparing, K is 6. Okay, and that's doing it by proof. Okay?
Wait, Miss, why didn't you try the 20 by 19 factorial?
Because I am trying to subtract these two numbers and I can't do 20 factorial minus 13 times 19 factorial. I need like terms. So I'm winding the 20 factorial down 1 and making it 20 times 19 factorial. So now 19 factorial is my common term. 20 lots of 19 factorial minus 13 lots of 19 factorial are 7 lots of 19 factorial. Okay? Now, theorem, we did look at this in our first introductory lesson before I set any exercises. We looked at the expansion of 1 plus x to the power of n. Does anyone remember that expansion? Do you remember it? 1 plus x to the 1 is, do you remember this? 1 plus x squared, let's see if you remember them. 1 plus 2x plus x squared. I'm going to write it all another way. 1 plus x cubed, do you remember it? 1 plus, yeah, plus 3x squared plus x cubed. So remember the coefficients. I mean, I can do the 1 plus x to the 0 is 1. But remember the coefficients of these terms, what are they? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What are those coefficients? That's right. So now, that's what we've learned how to do. I'll do one more. 1 plus x to the power of 4 is 1 plus 4x. Notice that the second term is the same as the power. 1 plus 2x, 1 plus 3x, 1 plus 4x. Now what would be the next one? 1 plus 6x squared, and we keep plus 4x cubed plus x4. Tell me a few things you notice about these numbers. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. What do you notice about? Symmetrical. They're like palindromes in a way. You read them the same forwards as backwards. So the coefficients are symmetrical. You read it the same forwards and backwards, okay? Now, instead of writing it, the terms like this, I can actually write them like this. So I can go 0C0, 1C1, no, 1C0 plus 1C1x. So what I'm writing here is using the C notation. Can you just do 0C0 on your calculator? Make sure you get 1, okay? All right. Now, 1C0, anything C0 is the number up here. 1C1x, that's how you write 1 plus 1x. Then what do I write next? 2C0 plus the coefficients written as 2C1x plus, what do I write next? 2C2x squared. And then I write 3C0 because that just gives you the 1 plus, what's next? 3C1x plus 3C2x squared plus 3C3x cubed. Now we're going to write the general term in a minute. And same thing using this C notation, 4C0 plus 4C1x. See, girls, we don't want to be always doing this. Later what you're going to do, you're going to give me the 5th term on the 20th row and you're going to know that it's 20C4, for example, the coefficient. So we're going to come up with a general term this lesson sometime, I think. Plus 4C2x squared plus 4C3x cubed plus 4C4x to the 4. Can you see that? All right, so that's how we write them. So now I want to do the general term. So my general term, or general expansion or whatever, or actually the expansion. Have you got that? That's general. Oh, it's actually not the general term, but it doesn't matter. Or in general, I meant in general. In general, the terms. In general, the terms of 1 plus x to the n. All right? In general, no capital G. So we okay? Do we get the idea of the thing, the pattern? So how would you write it for 1 plus x to the n? What's the first one? Look, 1 plus x to the 4 was 4C0 plus 4C1x plus 4C2. What do I write for the first one of 1 plus x to the n? Let's see. Do you have this other stuff or no? 1 plus x to the n is, yep, nc0 plus nc1x plus nc2x squared plus, there'll be a whole lot of terms, we'll do one more, plus nc3x cubed plus a whole lot of terms. Now what I'm going to do, I'm going to stick a term in the middle somewhere. I'm going to call it nck x to the k. That's just a general term. Okay, now I'll keep going. Tell me what the last term would be. Don't write it down yet. What's my last term? N. Well, look here, 4C4x4. What's my last term? Wait, leave a space here. NCN x to the n. What's my second last term? NC n minus 1, and I've got no room. NC n minus 1 x to the n minus 1. So girls, this is just any term in the middle, NCK, NK. Got that idea? This one, remember the n is always the same on top. If that's NCN x to the n, this is NC n minus 1 x to the n minus 1. Got the idea? That's the first term, second term, third term, fourth term. Just watch what I'm doing. Girls, the first term is NC0. Can everyone look and listen to the pattern? The second term's got a 1. The third term, see, first term. All right, let's look here. That's the first term. That's the second term. That's the third term. That's the fourth term. What do you notice about the powers? They're one less than the number of the term. Does that make sense? Okay, so do you remember how many terms you've got? Look here. 1 plus x to the 1 has how many terms? 1 plus x squared has how many terms? It's one more. So how many terms does this have if I've got to the power of n? That's right. So this is the n plus 1th term. N plus 1th term. This is the nth term. So this is which term? If this is the fourth term, it's a cubed. What's a k? What's one bigger? So that's cubed, that's the fourth term. Add 1 onto that to give you the number of the term. What term is this? Yep, that's the k plus 1th term. Now I need this written down as is. So NC0 is the first term, NC1's the second, NC2's the third. Got the idea? So first term, second term. This is important because we're going to be talking about, we always talk about the k plus 1th term. Now that's in that notation. That is called combination. That's using combinations. This is the nth plus 1 term here. The x cubed is the fourth term. The x squared is the third term. So you've always got one more term than the power. Okay, so if the power is n, this is the n plus 1th term. That is in combination notation. We can also write it in choose notation, n on 0, and it's got to be in these brackets, n on 1x. Notice there's no fraction line in between. Now, we can write that like that, but we can also write this binomial expansion. So this is 1 plus x to the n. I've just written 1 plus x to the n there. But it can also be written in sigma or summation notation. So we can also write it in sigma notation. Have you got that all down yet, girls? Yes or no? So now, we can write it also as 1 plus x to the n is the sum. Now, you write what the general term looks like. The general term is nckx to the k, nckx to the k. But what does the k value, if that's your general term, what does your k start from? NC0. X to the 0 would give you your first term. NC0, what's x to the 0? 1. That's why there's no x here. Then you've got NC1, x1, NC2, x squared, NC3, x cubed. So we say the general term looks like this, nck x to the k, and we're starting from k is 0 all the way up to k is what? If this is the, yeah, up to n. Okay, so writing this in sigma notation, we write it as general term nck x to the k starting from k equals 0 just up to n. You just put the n on top. So it looks like this. 1 plus x to the power of n, put an n on top, that's meant to be in the middle, sigma notation. This is k equals 0, so it's telling you you're going to sum all of these, starting with k is 0, then k is 1, k is 2, k is 3. You're going to add them all up to k is n. That's sigma notation. Or you can also write it as, in choose notation, 1 plus x to the n is the sum of all values from k is 0 to n of n on k x to the k. They mean the same thing. And if you look at that, don't we start from k is 0, n on 0, x to the 0, n on 1, x to the 1, n on 2, x squared, all the way up to n on n, x to the n. Do you get the idea? Yeah. Do you need to see what was there before? I'll just pause. The k plus 1th term. So the general term is the k plus 1th term. Okay, and the k plus 1th term is, what is it? NC what? What's the k plus 1th term? Anyone? NCK x to the k. So your general term is your k plus 1th term. It's NCK x to the k.
Is that over?
Not over.
What's the line then?
Oh, that's a heading.
Oh.
That's a heading. The general term or the k plus 1th term, this is a little heading. It's not a fraction line. That's a heading. The k plus 1th term is equals NCK x to the k. Put it in a box. That's your general term, k plus 1th term. Anyone? All right. We did this last time. There are how many terms in the expansion? Yeah. Just notes again. Remember, there are n plus 1 terms in the binomial expansion of 1 plus x to the n. For example, 1 plus x squared has 3 terms. Got it? 1 plus x to the power of 4. No, 1 plus x cubed has 4 terms. But it's easy to remember 1 plus x squared has 3 terms because it's 1 plus 2x plus x squared. So there are n plus 1 terms in the binomial expansion of 1 plus x to the n. And does anyone remember what the sum of the coefficients? Yeah. Of 1 plus x to the n is? So for example, sum of the coefficients of 1 plus x to the n. 1 plus x squared is 1 plus 2x plus x squared. The sum of the coefficients is 1, 2, 1, which is 4. It's 2 squared. These are the coefficients of 1 plus x squared, for example, has those coefficients. They're the coefficients, co-f's. They add up to 4, which is 2 squared. The coefficients of 1 plus x cubed are 1, I'm just going to write 3. 3, 1. You know the coefficients of 1 plus x cubed are 1, 3, 3, 1. What do they add up to? 8. Which is 2 cubed. The coefficients of 1 plus x to the 4, we did this the very first lesson, are 1, 4, what else? 6, 4, 1. They add up to 16. That's 2 to the 4. So therefore, the sum of the coefficients of 1 plus x to the n is 2 to the n. Good. So these are all really important things. Put them all in boxes. The general k plus 1th term is NCK x to the k. There are n plus 1 terms in the expansion, and the sum of the coefficients is 2 to the power of n. Question 1D. Expand that, 1 plus x to the 6. Find the sum of the coefficients. Find the number of terms. I reckon I'll fit it here. And then write it also in sigma notation. Power of 6, you can write it in the combination notation, 6c0 plus 6c1x, 6c2x squared, etc. But as long as you know them all, you could write it the other way, but what if you get one of them wrong? What's next? What's 6c2, by the way? 15x squared. What's 6c3? So, but then you now know that what happens? It goes back down, so you don't have to do the others. See, girls, what was the other rule? That 6c4 is the same as 6c2. Do you remember that? Because 4 plus 2 is 6. 6c5 is the same as 6c1.
I was running 1 plus 6x plus 6x.
No, it's 6c0 plus 6c1x plus 6c2x squared. Now, this is 15 again because notice that 6c4 is the same as 6c2. Do you remember that from last lesson? 6c5 is the same as 6c1. And 6c6 is the same as 6c0. Do you remember those? We can just write it here. Note, from 6c1 equals 6c5. 6c2 equals 6c4. We looked at that very first lesson when we were noticing patterns. And of course, 6c0 equals 6c6, which equals 1. So just note those things. All right, what's the sum of the coefficients? 2 to the 6. 2 to the n, remember? Sum of coefficients is 2 to the n, which is 64. All right, number of terms is n plus 1, which happens to be 6 plus 1 is 7. Can you write that in sigma notation? It's the sum from all terms of n, c, k, x to the k, starting from n is 0 to n is 6. And that's how you would do, unless I put 6c, yeah I do, I put a 6 up here, sorry. 6. Yeah, oh yeah, and that's a k by the way, thank you, and I'm doing it all wrong. So it's 6ck x to the k, starting from k is 0 to k is 6. That's right. Do it properly, not like me. The sum from k equals 0 to 6, you have to put the 6 here, 6ck x to the k. That is that written in sigma notation. Okay? Now, another example, your product, and you're probably wondering what I'm asking you to do, and write the expansion of. You can definitely write the expansion. What do you think they mean by writing it as a binomial product? It's just 1 plus x to the what? 8. Okay, girls, so as a binomial product, this really is 1 plus x to the 8. So question 3, write that as a binomial product. So that means 1 plus x to the power of 8. And just write out the expansion of it. You know how to write out the expansion? I'm sure you can write out the expansion. How do you write out the expansion of that 1 plus x to the 8? Or, girls, isn't it saying just, we can do it in that format if you want. Let's keep it in that format. The choose notation. But then you're going to have to work out what they are. So mistake up here on this first example, that was 6c5x5 plus 6c6x6, so the last term's x to the 6. Got it? Okay, let's keep going. Question 4, find the coefficient of x to the power of 4 in the expansion of, we're doing 4b, of 1 plus x to the 9. So find the coefficient of x to the power of 4 in the expansion of 1 plus x to the 9. This is where you need to know the general term. Power of 4 term. It's 9c4x to the 4. That's the term in x to the 4. The coefficient is the bit in front of the x to the power of 4. So the coefficient is 9c4, which is 126. Okay, one other question. Of x to the power of 5 in this expansion, sigma k 0 to n, 7 on k, x to the k. Isn't it just 7c? Yeah. It's basically 7 on 5, x to the 5 is the term. That's the term, so the coefficient is just 7 on 5. Which is 7 choose 5. Got it? Easy. Oh yeah, because it's the same as 7 choose what? 7 choose 5 is the same as 7 choose 2. And it's 21. Coefficient. Okay, two other questions. So, question 9D, find the third term of this 1 plus x to the 7. So I'm asking you for the third term, not the x to the power of 3 term, but the third term. What is it? Yeah, it's the x squared term, remember? See, the first term, what's the first term? 7c0. Second term, 7c2. Third term is 7c3. So, sorry, no, it's 7c. First term's 7c0, second term's that, third term's this, 7c2. Sorry. So the third term is 7c2x squared. So what is it? 21x squared. Now, this is how it starts. The terms go like this, etc. Right? They're the terms. But remember the formula for the k plus 1th term is nck x to the k. So the third term is k is 2. Do you get it? So for the third term, k plus 1, 2 plus 1 makes 3. Look, you've always got your NC0 first. So your 10th term will be the x to the 9. Got it? Your 20th term will be the x to the 19. Okay? And question 10, find the kth term of, question 10, I don't know, I think we're going to do a few of them. 10b. Find the kth term of this, 1 plus x to the 2n. Now this is a little bit tricky, so they finally throw in one, slightly challenging question. Find the kth term of 1 plus x to the power of 2n. How does this thing get written out? Let's start writing it out. The kth term is going to have a power of what? The third term, girls, was an x squared. So the kth term will be 1 less than k, which is k minus 1. What's your power? So the kth term, remember it's got to be of that format, nc k x to the k, but won't it be nc kth term? K minus 1, x to the k minus 1. Oh, and what have I not done? I haven't put the 2n. You put the power, ck, x to the k, kth term, but you always have one number less here. Reason is the k plus 1th term is nck x to the k. That's the rule you're using. So the kth term will be the k minus 1, and the power here is 2n, so you put the 2n up there. Now, that's what the kth term is. What about question 10a? I want the kth term of 1 plus x to the n plus 1. I want the kth term of that. So this is your answer for the first one. That's your rule. What's your kth term of that? Remember, it's of the format nck x to the k, where the k, it's n plus 1 c k minus 1 x k minus 1. All right? Now, for homework, because we still have to do what we have to do, homework, you can just do question 1, just do C. Question 2, you can do B and E. Question 3, you can just do B and D. Question 4, just do, I don't know which one I did. What did I do? Question 4. Just do C. 5, you can do D. 6, you can do B. 7, you can do D. 8, they're all the same type of question. 8, what did I do in 8? 10.1, 10.2. I didn't? Yeah, just do question 8. Oh, you're only doing one of each. Just do question 8. Well, I've got 8C. And 9 you can do, which one did I do? Just do A and E. Actually make it, yeah. And 10, you can do the ones I didn't do, C, D, E. I'll be giving you a video for 10.3. You'll be fine with it. It's just slightly harder. It's not even that bad. But I'll just do it by video before Thursday. I'm hoping, and then you can do the homework for that on Thursday in class. So I'll try and get this video done tonight. That's only going to take you